Imagine you are hired by a bar as a data analyst, and while analysing the bar's sales data, you find an interesting trade-off. When the drink prices are too high, customers order fewer drinks, but when the drink prices are too low, the bar's profit margins take a hit. By analysing the bar's sales data, you help guide a new strategy. You find that offering premium priced drinks early in the evening works best, as customers tend to splurge at the start of their night. But as the night goes on, demand shifts towards cheaper drinks as customers become more price sensitive. By dynamically adjusting the drinks menu based on the time of day and customer behaviour, you can balance profitability with higher sales volume, maximising the bar's overall revenue. And in essence, that is what a data analyst does. They collect data from different sources, clean, manipulate and organise it to prepare for analysis. Then they analyse the data to uncover valuable insights. And finally, they present the findings through reports or other visualizations to help inform important decisions. A data analyst relies on a variety of tools to perform their job efficiently, each suited to different aspects of the analysis process. SQL, or structured query language, is used to query and retrieve data from databases, allowing data analysts to manipulate and filter data. Excel is a versatile tool for data manipulation and basic analysis. It's often used for organising data, performing calculations, creating pivot tables, and generating quick insights, especially for smaller datasets. Python, or R, are powerful programming languages that can handle more advanced analysis and data processing. They are great for automating repetitive tasks, handling large datasets, performing statistical analysis, and building predictive models. Business intelligence tools like Microsoft's Power BI or Tableau are popular for data visualization and reporting. These platforms help analysts create interactive dashboards and compelling visual representations of data to communicate findings clearly to decision makers. You may be surprised to hear that to become a data analyst, you don't need to be a mathematical genius. In fact, the ability to problem solve and communicate complex findings effectively are far more important than advanced math knowledge. And creativity plays a bigger role than you might think too. When working with new datasets, data analysts need to think creatively to uncover valuable insights and answer key business questions. So, to sum it up, data analysts transform raw data into meaningful insights that guide key decisions and shape business strategies. If you are thinking about becoming a data analyst, a great place to start is by learning essential tools like SQL, Excel, and Power BI, before moving on to more advanced tools such as cloud computing, Python, R, etc. I hope you found this useful. Don't forget to like and subscribe for more. Thanks for watching, and I'll see you next time.